Let's dig into the artificial, I would say, intelligence neural world. So what we are seeing is artificial intelligence is a superset of everything, concerning, I would say, related to machine, mimic, cognitive capability like humans. So each time we are trying to copy or to have a mimic of human stuff, so it's in a big category of artificial intelligence. So, okay, it's covering everything. Everybody's talking about artificial intelligence. It gives you possibility to have some interaction with the environment, knowledge, perception, learning, and so on. These are the keywords we are learning. And these concepts are coming from computer science. So you need science, mathematics, statistics. Okay, these are the three stuff. But this is a superset. And inside the artificial intelligence, you have one of the subset is called machine learning. Machine learning then means that, okay, you will collect a lot of data set in this case, and then you will start to train based on this data set to, I will say, extract some information in order to learn and to have some, prediction in this case. So this is machine learning. So the machine will learn, in this case, you will use a machine to learn and to train your stuff. So it could be mathematics, it could be statistic, it could be, and I will show you some example. And inside the machine learning, what can we do? We have some pattern recognition. This has a keyword. We have some anomaly recognition, some prediction in the future. So it could be, stock price in the future, advertisement, and so on. Anomaly recognition. You have some machine, and then someone is trying to change the machine. You can recognize it. So this was okay. Bank are doing and other stuff, and also pattern recognition, trying to spoken word, facial identity, and so on. That's the key. You have three different kind of learning stuff in the machine learning. So you have the supervised, the unsupervised, and reinforcement. These are three techniques they have. One of the technique, and this is the one, is a supervised. So that means you will have data which are labeled. What does it mean? So if you want to recognize, I don't know, difference between the different animals, so we will put picture with cat, and you will label it as cat. You will put picture with dog or with other animal, and then you will label all this data. So big job to be done. So that means you have to prepare this data. And then you will start to have a learning process. So you will learn from this data, and then you will try to, based on different algorithms, based on different technique, I will explain this different technique after all. And the goal of this, after this learning, is to recognize. So this is one of the method. Second method is, we say, reinforcement. So you are showing stuff, and like I would say, dressing a dog. So if it's good, if the result is good, then you have giving in sugar or something which is good, and otherwise you end up. So it's a kind of what we say, it's a rewarding system. So we are rewarding, and you are learning. So your system is learning based on that. And the third one is unsupervised. So there is no control, there is no label. So you are trying to, on the fly, to have some category, and then after all, to decide what to do. The good thing is you can have a mix of this. So these are the big models. So this is triangle, but the learning is something in between. So you can use part of it and then mix. Okay, but this is a general stuff for machine learning. And within this machine learning, what we have is some of the approach. You have much more approach, but okay, these are the main approach, we found. So the first one is a decision tree learning. So decision tree, okay, we have the picture here, so it's quite clear. Based on the data set you got, then we are trying to extract some, feature, and then try to, I will say, the machine is trying to transfer it inside, yes, decision tree, if, then, else, and so on. Okay, this is one of the technique. Second technique is clustering. So trying to put, all the data inside clustering, and then trying to find the area where those clusters are to predict the next stuff. So this is a method based on statistic also and mathematical stuff. We have rules-based learning. So this is something different. We have inductive logic programming, Prolog. You can have a look on the web. So it's different kind of things, mixing statistic and mathematical phenomena. And the last one, and this is the one we have interest today, is called deep learning, and using neural network in this case. Deep learning neural network, so this kind of stuff. And this is where we are focused. But deep learning is again a subsystem from machine learning. Okay, at ST we are also using decision tree learning and clustering. So we also have algorithm on our sensors. So we have sensors, for instance, which are embedding some decision tree learning. So inside. So this is AI, of course. We are calling it AI. This is machine learning, but in this case, it's not neural network. Now we will dig it a little bit more inside this part. Deep learning neural network. Why? And this is why we are explaining this. Because what we have seen in neural network deep learning is existing since a long time. It was going up and down because of resources we had, because of the performances, the data set we are able to collect. Why? Because we have some advantages of the deep learning and disadvantages. What we are saying is not it's ideal for everything. So at the end, what you will realize during if you have no experience on the AI from now, so you will have to try maybe all of this and then select the best for you at a T time, and then maybe we'll change based on the amount of data you will have, based on the accuracy you need, and so on. So what we are not saying is, okay, this is the ultimative. No, this is one of them, and this is one which is quite complicated normally to port on the microcontroller. For this one, you already have some, we say, software which are existing on the web, which are converting, this in C code. So this is existing, but for this one, there was from now nothing or not so much, and it's the reason why we are concentrating on this one. What are the advantages of this one, of the deep learning? Is there? Advantages is, okay, high accuracy, and what we are saying is, okay, you have the performances and you have the amount of data. And at the beginning, I would say, let's say that the normal algorithm, decision tree, clustering, rules-based learning, and other stuff are more efficient than the deep learning, because deep learning is quite complicated to put in place. It's requesting high computation and so on. So these are the disadvantages. But at the beginning, okay, you will see advantages of other algorithms. And then there is a breaking event, so it depends on the application. Question is when it's happening. Okay, it depends on the amount of applications, depends on the complexity of your application. But then you have a break event, and then the deep learning is continuing, to bring you some performances where the standard learning algorithm are stopping somehow. Why stopping? Because with the decision tree, it's the amount of memory space you have in this case. So somehow, each time, for instance, you're getting new data, you will change completely the structure of the tree. So it could be difficult to qualify in some case, depending on what you have, and so on. So disadvantages is you need a large data set to start. So when I say large, it's really large. I mean, it's a big amount of data to record. Disadvantages is a weak theoretical explanation. So it still look like a black box in most of the case. It's running. I have a customer. We were working 5 years long on algorithm, trying to detect some characteristic, doing some kind of predictive maintenance based on the audio. Spend 5 years, develop algorithm based on mathematical stuff. And at the end, they get something which were almost working, let's say. So it was working, was recognizing what they want. And then some condition change in the room, and then everything was gone. So all the 5 years was not working anymore, so they had to rechange and all the stuff. And okay, it was a lot of job. And then they engaged 2 AI guys and to try to use a neural network in this case. And this guy had a success after 2 months, really first success. And it was so successfully that okay, within the 2 months, I achieved to have at least at the same level at the 5 years development before and more, because then there was not big impact about the change in the environment. So they are really, but the big issue they had was to explain it, because it was safety based in this case. So they had to explain it to the final customer, and they were not able. So they had a good algorithm which were working well, but there were problem to explain why it was working so good in this case. Yeah, it could be the problem. So this is the disadvantages. We have to put it also in the balance. So what we are saying is not obvious that, okay, this will be, the right algorithm for you in each time and each. It's the reason why most of the people and the partner are talking about machine learning in this case, because they are proposing, different algorithm, which is okay in this case, yeah. Other comparison. okay, to be honest, these are the problems, I mean, in the AI since the beginning. So problem of object classification, so which are object, we are showing some object classification in this case, scene classification, audio scene or other stuff, object detection, you are putting some 1000 objects, different object or more, and then you have to detect it. And then you have some data sets which are on the web. So you can download all this big data set, and then you can leave your algorithm running. And these are the best accuracy you got without using the conventional, I mean, we say neural network in this case. So, and okay, for some of them it was quite good. I mean, in this case, face recognition 96.3, so quite good with conventional stuff. For some other, it was okay. And on the right-hand side, you have the best accuracy using the neural network. And then you see some plus. In some case, you have some plus, big plus, and some case not big plus. So it's not obvious again. So it's really depending on what you are doing, what you plan to do. This is the message. But in some cases, it's broke so much that some of the people said, okay, we'll not use any more conventional stuff, depending on the the problem you had. We'll use no CNN, and they are focusing on the neural network stuff.